Hello, so we are going to be solving quantum physics, a question on quantum physics. I'll read the question and then we'll tackle the problem together. Let's go. If psi is equal to a exponential minus alpha r cubed minus I d in spherical coordinates, where a, alpha, d are real numbers, normalize psi and find the probability that the particle is between r is equal to 1 and r is equal to 3 units of length. Now we are given an int. Int, if psi does not depend on theta, phi, the volume element detour is equal to 4 pi r squared dr. Make the substitute u is equal to 2 alpha r cubed during integration. Okay, so we have this question. Let's see how we can solve this problem together. Okay, now the first thing is this. They say we should normalize psi. Okay, so we are going to be normalizing psi using the word the normalization condition. And what is the normalization condition? The normalization condition is this. Solution. The normalizing condition is this: integral minus infinity to infinity psi dot psi conjugate, okay, detour is equal to 1. So this is a normalizing condition because we are asked to normalize psi. So to normalize psi, we are going to be using this normalizing condition or normalization condition, which is this. So we are giving psi to be what? Psi is given to be equal to, in the question, psi is given to be this. So we have a exponential minus alpha r cubed minus I d. Okay, now what is going to be the conjugate of this psi? Is simply going to be this a exponential. I hope you can see to this point, a exponential minus, this is still going to be minus because it's not having any complex number this side. Okay, so we have minus alpha r cubed. This is going to be positive because it's having complex number, so it will change to what? Positive I partial d. Okay, so now we are given detour. We are given detour to be equal to what? Detour is equal to what? 4 pi what? R square dr. Okay, so detour is given here. Okay, but please mind you, we are also asked to make the substitution u is equal to 2 alpha r cubed during integration. So you will see how we're going to apply this while integrating. Okay, so I'll wipe the question and remember that we're finding the probability that the particle is between r is equal to 1 and r is equal to 3. So I'll wipe the first part and then we'll find the we'll normalize psi using this normalization condition. So this is what we are going to be using, the normalization condition from this to this, from minus infinity psi dot psi conjugate detour. So we substitute everything. We have found our psi, we have found the conjugate of psi, and then here is detour. We substitute it into this equation. So if we do this, we'll have this. What is psi? Psi is this. We have a exponential minus I only recopied what I have here into this, then dot this, the conjugate, we have a exponential minus alpha r cubed plus id, and then we have detour to be what? Dot what? 4 pi what? R squared dr. Okay, so we have this. So if we multiply this and this, we'll come with this. We'll come up with this times this will give us a squared. Okay, it will give us a squared. Okay, let me just do this step. So we'll have this. Okay, this times this will give us what? A squared. So the exponential will now have exponential. This will cancel this. Okay, but this will sum up to be what? Minus 2 alpha r cubed. Okay, and then we have what? 4 pi r squared dr. Okay, so now let's bring out all the constants to this other side. So if we bring this 4 pi a squared, we'll have what? 4 pi a squared. Okay, we are bringing this to this side, we are bringing this to this side. Okay, so we have this minus this to infinity, then we'll be left with what? Exponential minus 2 alpha r cubed. Then this r squared, we have r squared what? dr. Okay, so what do we do next? We are going to substitute. Remember they said take u is equal, during integration we should use take u is equal to 2 alpha r cubed, and this is 2 alpha r cubed. Okay, so we substitute. So if we substitute, we'll have this. We'll have 4 pi a squared, all right, this minus u, right, r squared dr. So we want to do something. Since we know that u, okay, u is equal to 2 alpha r cubed, we'll differentiate this with respect to r so that we can find r and then substitute here to simplify this problem. Okay, so if we do this, we'll differentiate this. Du dr will be equal to what? This times this will give us 6 alpha r. Okay, then we'll minus 1 from this, then we'll have 6 alpha r squared. Okay, but mind you, we want to substitute dr. Okay, we want to substitute, we'll make dr the subject of formula from here. If we do this, we have, okay, let's cross multiply. So we have du is equal to 6 alpha r squared, right? If we cross multiply, we have this times this dot dr. We want dr to be the subject of the formula. So we divide both sides by 6 alpha r squared. Divide this side by 6 alpha r squared. This will cancel this, and then dr will be equal to du all over 6 alpha r squared. So we are going to be substituting this into this. Okay, so permit me to wipe this side. So this equation becomes, if we substitute, it becomes 4 pi a squared, this exponential minus u r squared dr. We are substituting with this, it becomes what? Dot what? Du all over what? 6 alpha r squared. We substituted dr in place of du all over 6 alpha r squared. That's what we did here. Okay, so this will cancel this, all right, and then we'll be left with this and this. We will take this to this other side since it is a what? A constant, and then we'll have 4 pi what? A squared all over 6 alpha, right, integral exponential minus u du. You see, we have simplified it now. We have simplified it now. So the next thing we'll have this, we have minus 4 pi a squared all over 6 alpha into e exponential u. This minus sign is because of this minus here. Okay, so for r is equal to 0 and u is equal to 0, that means when r is equal to 0 and when u is equal to 0, we have r, and when r is equal to infinity and u is equal to infinity for this condition, so we have 0 to what? Infinity. I omitted something in my condition. Is equal to 1, is equal to 1, is equal to 1, is equal to 1, is equal to 1. Okay, so we have is equal to 1. All right, so we have this information. So let me wipe the upper parts. If we wipe the upper parts, then we have this. Okay, so this becomes simply everything here tends to 0. So we have, tends to 1. So we have 4 pi a squared all over 6 alpha is equal to what? 1. So this is a normalized condition for psi. We are going to make a squared the subject of the formula here. So we have to do this, we have 4 pi a squared. This times this will give us 6 alpha. So we divide both sides by 4 pi. We divide this side by 4 what? Pi. This will cancel this, and then we have our a squared is equal to what? 6 alpha all over 4 pi. If we divide both the numerator and denominator by 2, we have 3 alpha all over what? 2 pi. So this is a squared. So we are not going to stop here. We are going to be substituting a to find the normalized wave function. Okay, so the normalized wave function, the normalized wave function will now be, okay, remember we have psi is equal to a exponential, I don't know if I can still remember, minus, I've wiped it, minus I can't, minus, let me check my notes. Psi is given as a minus alpha r cubed minus alpha r cubed minus id. This is psi. So the conjugate was given as this, a exponential, right, minus alpha r cubed plus id. So if we substitute a here, okay, so that we can have our wave, normalized wave function, this becomes, okay, for normalize now, okay, I'll be substituting a, okay, so I'll add n here to show that it is what? Normalized. I'll substitute my a here, okay, I'll substitute my a here. You see a squared. Okay, so if we remember this is a squared, so it's a we need. So it means a will be equal to the square root of 3 alpha over 2 pi. Okay, so it's a. So I'll wipe this a. Please, sorry. I'll wipe this a. If I wipe this a, I'll substitute it with this. So we have 3 alpha all over 2 pi. The square root is normalized. So to normalize this side too, I'll wipe, clean this, replace this a with what? This, and then we'll have 3 alpha all over 2 pi this. Okay, now the question says we should find the probability, okay, the probability that the particle is between r is equal to 1 and 3 and r is equal to 3. So to find the probability, this is the formula we're going to be using. To find the probability, we're going to be using this. So it's going to be P is equal to integral from minus infinity to infinity psi n, that's normalized wave function, then multiply by the conjugate, the normalized conjugate of psi, then detour. I hope you still remember what detour is. Okay, we're given in the int 4 pi r square dr, I think so. Okay, so we are going to be substituting this into this equation. So if we do this, we have P is equal to minus infinity to infinity. Psi n is what? We have this 3, okay, exponential minus alpha r cubed minus id dots. I hope this space will be enough. Let me manage. So we have this r cubed minus id dots. This is psi, the conjugate, and this is what we have. We are going to substitute it 3 alpha, okay, 3 alpha all over 2 pi, okay, exponential of minus alpha r cubed plus is conjugate, so plus, then detour. Okay, so we will substitute detour later. Let me simplify this. If you multiply this by this, if you multiply, that's the rule of surd. Okay, when you have a times a is simply equal to what? A is simply equal to a. Why? You have this a squared. A times a will give us a squared. So this will cancel this, and then you will be left with a. So using this principle, it means that this will now be equal to, from minus infinity to infinity, this times this will simply be 3 alpha over 2 pi exponential. This will cancel this because it's positive negative, so it will go. Then this and this will sum up to give us minus 2 alpha r cubed, and then we have our detour. So let's go up and continue. So permit me to copy the last step. Let me copy the last step. So if I bring what we have, the last step there, we have p is equal to this minus infinity to infinity 3 alpha all over 2 pi. I'm just recopying what we have here. Exponential minus 2 alpha r cubed detour. So now we can substitute detour, but before we do that, okay, let's substitute detour first. So we have detour. We know that detour is equal to 4 pi r squared dr. So we substitute this, we have this, I have 3 alpha all over 2 pi exponential minus 2 alpha r cubed. Detour is going to be replaced with what? 4 pi r squared dr. Okay, so let's bring the constants to the other side. So we'll bring this one to the other side. We'll bring this 4 pi to the other side. Okay, so we have p is equal to 3 alpha over 2 pi times 4 pi. We are bringing this to this side. So we have this. We'll be left with what? Exponential minus 2 alpha r cubed dot r squared dr. Okay, so if we simplify this, pi will cancel pi, right? 2 here will give us 2. 2 times 3 will give us 6. So we have p is equal to what? 6 alpha into minus infinity to this exponential minus 2 alpha r cubed dot r squared dr. So if we say, let's, just like the int we're given, that let u is equal to what? 2 alpha r cubed. So it means we can substitute this. Okay, now let's find the differentiation. Du dr, if we differentiate, I've done this before, let me do it again. Okay, du dr, we'll find it. We'll have du dr. If u is this, so it's going to be, I'll just go straight up. We have 6 alpha r squared. Okay, so if we want to make dr the subject of the formula, you cross multiply, you have du is equal to 6 alpha r squared dr. Dr will now be what? Dr will now be equal to what? Du all over 6 alpha r squared. Okay, so this is dr. We are going to be substituting dr into this equation, and we'll substitute for u into this equation. I hope you understand what we did. I hope you understand. So permit me to wipe. So we have our dr to be this. Okay, so I am going to be okay, let me just do this again. We have p is equal to 6 alpha minus infinity to infinity exponential minus u dot r squared dr. So this is my dr, right? Du all over 6 alpha r squared. Okay, is that okay? So r squared, we cancel r squared. We can bring 6 alpha here. So if we do that, we have 6 alpha all over what? 6 alpha, okay, minus infinity to what? Infinity. We are left with what? Exponential minus u du. This 6 alpha has come to this side. Okay, r squared. So we are left with this. Okay, so now for r is equal to 1, for r is equal to 1, u will be equal to what? From this formula, we have if 2 alpha is equal to r cube, if we substitute 1 here, okay, 1 times 1 times 1, 3 times will give us 1, okay? So we have what? 2 alpha, okay? For r is equal to 1, u will be equal to what? 2 alpha. Then for r is equal to 3, if we substitute for 3 here, I mean for r cube, 3 times 3 is 9, 9 times 3 is 27, 27 times 2 alpha will give us u is equal to what? 54 alpha, okay? 54 alpha. So I want to take it up, okay? So now if we do this, the equation becomes p is equal to, this will cancel and be 1, okay? It will go, and then we have exponential minus u. Remember, because of the minus in the exponential, we have what? 2 alpha, and then we have, for u, 2 alpha, and then we have 54 alpha, okay? So if we further simplify, what we have down there, if we further simplify what we have down there, I hope you are seeing, okay? This equation becomes p is equal to, all right, minus, we'll substitute for this minus u, we have minus 54 alpha minus exponential minus 2 alpha. Then we'll close the bracket. So if we open this bracket, this becomes minus exponential minus 54 alpha, right? This becomes plus what? Exponential minus 2 what? Alpha. So we can rearrange this solution. If we rearrange this solution, we have p is equal to what? E exponential minus 2 alpha, right? No, yeah. Then minus exponential minus 54 alpha, and this is the what? The answer, okay? That's the probability for when r is equal to 1 and r is equal to what? 3. This is the what? Probability. So I hope you enjoyed today quantum problem solving. I'm still Bukola Joseph. Bye.